Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna share the techniques that I use to create this. I call it like a chicken writings of numbers. You can see that for every numbers here, we don't have any single letters that's exactly the same. They're all slightly different, slightly randomized. For the positioning of the numbers itself, apart from it's being in a grid, I can randomize it in horizontally, vertically, or even like in the z-axis. So we have a lot of freedom there, and then the tag itself can be randomized, so I can go crazy and make it looking like that, but I can kind of reduce it as well until it becomes a letter, and they are all kind of the same. They are all based on my mouse hand strokes. So this is actually how I started. I started with a grease pencil and just writing numbers from 0 to 9. I'm using numbers not instead of alphabet because for simplicity, and you will realize that it's not actually hard to convert these numbers. Since it is already numbers, it's very easy to do all this in Sverchok. You see how many nodes we have to do this kind of crazy, kind of a cool setup of procedural numbers being scattered. Before, I think we just get started. Just start from scratch. I'm gonna save this real quick. This is gonna be chicken writing numbers. Yeah, let's get started. First of all, go to top view. Just write some numbers. Just use grease pencil, hold D, and start writing numbers. For some numbers, actually, like number 4 or number 5, it has 2 strokes. Number 6, 7 also has 2 strokes, and then 8, 9. We don't need to write 10 because we can use 1 and 0 to make 10. So that's one thing. Now I can convert this grease pencil into curve. I could actually keep it like a grease pencil, and we can process the grease pencil inside Sverchok. But it is up to you how you want to decide to pre-process the data. You will learn that for every project you have some kind of pre-processing, and then the actual process, the actual procedure, and then maybe post-process in the end. Pre-process is when you kind of make sure the data is all ready to be processed, because sometimes you can't just put the data in right away. For example, with this letter, if you just bring it into Sverchok, you might find that some of these numbers actually have few strokes, and if you bring them into Sverchok, you'll have to kind of filter out the numbers based on the orders and also sequence, and then you try to separate the numbers into each and every part. That's actually much easier if you do it manually, especially for numbers. Really simple, and alphabet as well. Alphabet like A to Z is really simple, but imagine if you're using like Arabic words or Chinese lettering or Japanese, or they all have multiple strokes, and then it's gonna be very difficult in order to separate them, unless you have some kind of algorithm that's dealing with this kind of like algorithm that understand letters or numbers or like characters. Anyway, for simplicity, I'm just gonna separate these numbers manually. Separate by loose part. Actually, I can't do that with curve. I need to convert this to mesh. So now this guy is mesh. I can separate it. Gonna save it. Whoops, file save as. Sorry. This guy separate by loose part. Now every single numbers is like a separate objects, including the strokes. See, number 4 is you have 2 separate strokes. We want to make it nice and clean. So with the number also, I want to give it a number, just number 0, and then name it properly, number 1. This is a tedious. You can do this using script, but for what we are doing, we can just do it manually. It's only 10, you know, just take a bit of time. 5, join it. See, I just simply join it manually and then name it number 5. This one number 6, number 6. Oops, it's supposed to be 6. Number 7 made up of 2 strokes. So this number 7. We have number 8 and number 9. The naming is important when you're dealing with data and multiple of data. If you name them properly in order, like in this case the number, they are in order, and you can easily reuse them at any time in point. Now we have all of them, but another thing that you want to do is to probably set the origin to itself. So I'm selecting all of them and set origin to geometry. So now each of the objects have centered. They are being centered, and they are good and clean, and they're ready to go. You just need to bring it into Sverchok. I'm gonna select all of them. Just box selects using hotkey B. Go to Sverchok and objects in. You can actually use animation nodes to do this, but I'm using Sverchok because Sverchok is really cool when it's dealing with mesh data. Animation nodes can do the same thing at some point, but for now I'm using Sverchok. Get selection. Now I have number 0 to number 9. I believe they are all in order. They are good to go. I'm gonna test it with a viewer draw and list item. So each and every data, like this points for 0, for example, I want to test it. Do we really have the points correctly? So we have like some dots. Wondering what is that? Maybe apparently we need to be on level 1. This level thing is something that can be slightly confusing or if not like intimidating for user. Basically, you can think of this level like a kind of like a zoom level of components of objects, because if you think about it, if you think of an object is made, like say you have like a box. Okay, a box can be made up of components. Maybe it's made up of points and made up of edges and also made up of polygon face. Okay, that's for a box. Imagine of a components of let's say you have like a building. You can have like a different level of buildings. You can separate every part of the buildings, and for every part you can also make it even smaller parts. So that's like a zoom level. So that's how the data in Sverchok actually being organized. You can oftentimes you need to check which level you want to work with. Level 1, level 0, level 2 is probably the first points of every letters. Now we don't want that, you know. This is like using every points of the character. That's not what we want. We want like the letter as it is. So we have 10 of them. You see, I'm using this list item just to get to the item of the objects. So cool, that's been taken care of. This guy, these letters, they are our source. This guy is gonna be the final thing. Okay, we're gonna continue on with this setup. So we know that it is working with our objects, and we have control over the data. We have 10 different data. You think of it that way. 10 different data, and you can place them in a grid, for example. So for this data, instead of using list item, you can do it like this. Just plug all these 10 data, and then if you give it like transformation matrix, you give it like line 1 2 3 4 5 6 7 8 9 10. So we are arranging this 10 data in a line. Okay, that's simple enough. There's a cool thing that you can actually do. You can use list item and just plug in into this guy, and now you see, because we have like a 10 transform here, transform data, we are actually giving this 10 slot of data they're dependent on this the item we are listing, depending on which index that we are using. So index 0 is actually 0. That's the convenience of programming. Number starts, index number start from 0. Okay, that's cool. And even cooler is we can use random number generator, and we are gonna be using just integer. And for this thing, size 10, integer low and height 0 and 10, you can plug this into that guy, and then you can see now we have random number between 0 and 10, and we are giving like a random number for each generations of or for every slot of this. So that's cool, right? That's actually really cool. In fact, instead of using like line points for our transform, we can use grid points. I'm gonna use plain. Plug this into the matrix, and we can have, let's say we have 5 by 5, 25, so 25 of variations, and we can spread them. Now we have this kind of a grid of numbers. Okay, so that's actually how you can start doing this and start making variations, and depending on how you want to do this. You see that if I'm adding the points for the transformations, this random number doesn't actually update itself unless you are actually making it that way. So you can do it. You can use list length. So this is another function. You've seen me doing this many times. Use the stethoscope and check it out. So what's the number? 80. Okay, 80. So that's the number that we need to plug in into this guy. Okay, so that's it should be clear enough. Now the number variations match the number of points transform we have. You can, of course, with this matrix transform, you don't only have like the point positions. You can also randomize the scale slightly and randomize the rotation slightly. It's totally up to you. So we can now, increase the number. Oops, that's a lot. 20 by 8, that's a lot. 160. Everything will update accordingly. I have a feeling that this number is not correct. Let me double check. It says 160. It is 160, but this size is not. There seems to be a funny thing going on there with the seed. You see, we're getting 1111. That's kind of weird. Let me cut this and give it 160. Still getting 1111. Wonder why. Maybe I'm doing something wrong here. Level 2, level 1, level 0. Why is the size of 172 giving out 157? That's That's a mystery there. Let me try 20 by 20. So we have 400 of this, and give it 400 here. We are only getting 367. So that's a little bit strange. Something I need to check there. If we check in with the stethoscope, maybe we have list of 400 items, int 400. Maybe we need to join this or somehow to, with this vertices, we need to join them. Please join. No, I don't think we need to do that. It's just slightly weird. So we have these 10 items, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 items goes into list item. We are not getting 400 from here. So that's a little bit weird. And if I randomize the seed, this guy is also changing. So that's some things I need to take care of. I need to ask the developer. But anyway, we have this thing going on, so that's alright. So make it like 20 by 5. We have 100 variations of this guy. Make sure we have enough random number being generated. Should be enough. Give it like 200. Randomize the seed. So we are good. We can actually use anything, not just numbers, but any kind of objects that's in order from 0 to 10. You basically have 10 sampling value there that you can play around with. Imagine if you want to use like not the numbers, but some kind of pattern to generate or to resample something. So based on the value, 10 kind of sampling of value, you can kind of measures for each points sampling. You can measure, okay, this point is like 0 in value, this point is like 9, this point is like 5. You can actually play with that idea. Maybe that's gonna be for another live noding. Anyhow, for this, what else you can do? Like I said, you can randomize the input vertices, for example. So the text is not exactly in the grid. You can randomize it slightly. It's always good to add some variations. You can use random noise or things like that. If the text is too high in resolutions, you can always use vectorized interpolation, vector interpolations, and you simply plug that in there, and you know that you can simply use float range from 0 to 1. Just give it a value, and then you can simplify these numbers. Okay, the number is being simplified now, but they don't have any edges yet. If you notice that for the edges, we can simply use the UV connection. UV connection might have a little bit of just a slight issue if the number have multiple strokes. So you need to be careful with that. Like this number 4, because it have 2 strokes. This UV connection is just connecting everything. So that's one thing you need to keep in mind. Maybe I can cut it somewhere. Nope, don't worry about that for now. there could be like a better way to handle such problem. Maybe we don't need to worry about edges for now, just the points. And with the points now, if you want, you can also randomize input vertices here. This guy will all have some slight, they all have like the same random value unless you use a range integer and you actually give it a different seed for every single numbers. That way every numbers has slight variations there. Oh well, I think we do need to have the edges. So anyway, even though the edges is not perfect, it's still better to have it this way. And maybe less random. So we have our chicken number writing. You can see this number 4, number 3, this is a little bit weird, number 1. Maybe this is like the person or the chicken writing these numbers are a little bit shaky. Maybe it's not chicken, it's like a cricket. Sverchok actually means cricket in Russian or in Ukraine. Okay, so that's I guess pretty much it for this live noding. This is the chicken writing numbers. I guess thanks again for tuning in. If you have any questions, suggestion, feedback, let me know in the comment section below, and I'll see you in the next video. Thank you. Bye.